Okay, this is a little bit more of a fancy U substitution. You're still going to follow the same pattern, but when we make the substitution, there's going to be a little bit more of a complicated turn of events. So I'll do as before. I'll pick U to be something in the parentheses, something in the square root, x squared plus 1. In fact, I'm going to do this over here to just save myself some space. U equals x squared plus 1 du, that's 2x dx. Okay, so let's see what we can do with our substitution. This part's easy. This is the square root of u. Okay, now I still have x cubed dx, and I can get one of these x's with the dx from here. I can say that x dx is equal to du over 2, so that takes care of part of it. So there's the du over 2. But I still have x squared to deal with, and from that, I'll use this here. X squared is equal to u minus 1. So one of these x's is over in this part, and then the other leftover 2 x's, or the x squared, I'm going to substitute into u minus 1. Okay, so not too bad. Now, this is equal to the integral. I can multiply this out. When I multiply the u and the square root of u, I get u to the 3/2. And when I multiply -1 and the square root of u, I get u to the 1/2. So this is equal to 1/2. When I add 1 to 3/2 here, I get u to the 5/2. And then I'm going to divide by 5/2, which is the same as multiplying by 2/5. I'm going to now integrate this. I'm going to add 1 to the exponent. That gives me u to the 3/2. And then I'm going to divide by 3/2, which is the same as multiplying by 2/3. Add a constant. It's an indefinite integral. And my last step is to convert the u's back into the original form, which is u equals x squared. U equals x squared. Okay, so this is 1/2 times, I guess I could cancel the 2's. Let's cancel all these 2's and write the answer in a little nicer form. So I have u to the 5/2 over 5. That's really x squared plus 1 to the 5/2 over 5 plus x squared plus 1 to the 3/2 over 3. Okay, so that's your answer for number 30. Okay, let's move on to this one here. This is number 40. So for this one here, I'm going to pick u to be pi t. Then du is equal to pi dt. So I'm going to substitute here. Now I'm going to ignore these bounds for a minute. And I'm just going to do the anti-differentiation. Then when I put everything back as t's, I'll put the bounds back in. So for the time being, let's ignore that. What I get here is cosecant of u, cotangent of u, and then dt is the only thing I haven't substituted for. dt is equal to du over pi. So I have a 1 over pi du. This is equal to 1 over pi times the antiderivative of this. The antiderivative of cosecant u cotangent is negative cosecant. I'll put the negative out here. Negative cosecant u. And so my integral that I want to compute with these bounds is negative 1 over pi cosecant of u, but u is pi t. And I'm going to evaluate that from 1/6 to 1/2. Okay, so what's that? Remember that cosecant of t is 1 over sine of t. Okay, so when I calculate this, I'm really calculating sine and then I'll do 1 over it. So this is negative 1 over pi times, okay, what is cosecant of pi over 2? That's 1 over sine of pi over 2, which is 1. And then I have cosecant of pi over 6. Sine of pi over 6 is 1/2. Sine of pi over 6 is 1/2. So we're talking about 1 over 1/2. 1 over 1/2 is 2. So this is equal to 1 over pi. Okay, there's a negative here and a negative 1 in there. Now I'm going to go over here on this little space here and do the trigonometry for you rather than just talking about it. So I have cosecant of pi over 2. That's the same as 1 over sine of pi over 2, which is 1 over 1. Okay, that's this one right here. Then I have cosecant of pi over 6. That's the same as 1 over sine of pi over 6, which is the same as 1 over 1/2, because sine of pi over 6 is 1/2, which is 2, and that's this 2 right here. Okay, so the final answer is 1 over pi, and that's the complete solution. Okay, that's it.